I'm actually going to also point you to a URL for, and starting to turn that into a game to teach a bit of machine learning and AI. And then I'm going to let's see, I'm going to talk about intelligence and what that is and what AI is, and why we need to be concerned about it, and try to focus on beneficial AI. You know me and Maria at Tangible AI. These are some of our projects. We're working mostly on natural language processing projects, which many people consider to be AI, because once you have a machine that can read books, then it can get pretty smart pretty fast, and it might be able to be smarter than us. So if you want to learn more about artificial intelligence, anything better, and it was in Python. These guys are both super smart. I'm going to talk about the second guy who came up with this idea of beneficial AI, and or at least sort of popularized it. Agents. What is an agent? What is an AI agent, an artificially intelligent agent? An agent is something that just makes decisions in the world. So most of the algorithms that we build every day, they're making decisions, and so you can really think of them as almost AI. The key, though, is the I part of AI, an intelligent agent. You don't want just an artificial agent, just a machine. You want it to be an agent that's also a little bit smart. Some of the big challenges recently that have kind of been hot, obviously, was AlphaGo. So that was a demonstration that, oh, wow, yeah, okay. So we knew they could beat us at chess, and I'll explain why that was kind of expected. But to beat us at Go, that was quite a big deal. They beat the world champion Lee Sedol in 4 games out of 5. There was supposed to be only 3 games, but Lee Sedol kept going and eventually did eke out 1 win out of 5. A pretty awesome match if you want to see it. There were 2, if you're a fan of Go, there were 2 hand of God moves made by AlphaGo and not by the human. You don't typically see those except once in your lifetime in an actual game that you're playing. And Lee Sedol got to see 2 of them, and they weren't his. So an intelligent agent is an agent that makes decisions that are expected to produce its objectives. Obviously, the objectives are pretty well defined in a game of Go. And so that's why these intelligent agents are doing so well. So chess has 10 to the 43 or 10 to the 47 possible moves that you need to know about so that you can make a decision at one of those positions. And that's a big number, but and it's approximately the same for shogi, which is a variation of chess played in China. Go, however, is a much bigger board, and it has 10 to the 170 possible decisions, or 10 to the 170 possible boards that you have to envision in order to plan out where you need to go and what you're going to have to do at those various positions. If you want to exhaustively search that tree, that's how far you'd have to go. And that turns out to be 100 orders of magnitude bigger than the number of atoms in the universe. So it's a really, really insanely big number. And yet the machine was able to generalize well enough to pare that down to just the boards that it needed to know about, the ones that were good, and find those good ones and get there for itself. And it did this in a completely unusual way. So AlphaZero, they originally called it AlphaGo Zero because it started from 0. They gave it nothing except they gave it a simulated board and said, hey, play yourself, figure out how to play. And then they pitted it against Go champions, and it was it quickly beat AlphaGo, and then of course they knew that it would be able to beat a human as well. And it did this. It trained itself to do that by playing these games in the course of a day. All three of these games it conquered in a day without it knowing anything other than, it was not even told the rules or any of the strategies or any of the opening gambits that people typically play. It just went to town on itself and figured out what the rules were and eventually killed it. All it had was a survival instinct. Keep your pieces on the board and stay alive as long as possible. And it successfully did that. So it's a little bit scary that we're able to build machines now that can solve virtually any constrained game in record time and beat us at it. Extremely complex games. But people still see that as kind of slow progress. So we're still thinking of a lot of people think of what we've done in AI to be kind of like what the Industrial Revolution was. We're building factories, we're building bigger and bigger computer farms, and we're building bigger and bigger AI algorithms that are moving faster and faster. So we built trains that are longer and longer and bigger and bigger with more and more powerful steam engines. But if you consider that we're probably making a big leap here, and all of society is on this freight train, it's not like it's just like one business that's on this freight train or one business's welfare that's on this freight train. AI has the potential to carry us all along with it. So you can imagine it's more like the nuclear age and around World War II, where there was this race to produce this. Because right now there's a huge race, especially between China and the US and perhaps Russia and Europe, to try to build an AI system, because there are trillions of dollars per year at stake for the first AI that is generally intelligent and able to surpass what a single human can do and start designing itself better and better than its own humans that are designing it. So at that point, it becomes a runaway freight train, and it's no longer just a tool, and it's taking all of society with us. That's what brings us to human compatible or beneficial AI. So this is Stuart Russell, who was the second author of that book. He's the one who's more interested in symbolic AI, symbolic processing AI, as well as what's called Bayesian logic. So building Bayesian reasoning systems. These are links to various pro-social sources for purchasing these books. So Stuart Russell, definitely, if you read only one book on this page or one book this year, highly recommend Human Compatible. It's built on all if you want to actually prove some of the things he's talking about, you can go back to his book, Artificial Intelligence Monitoring Approach, and implement them in Python if you like. Really lots of fun, including algorithms to solve chess and other simple games. Artificial You, another book, just came out at the exact same time, and it talks about a lot of the exact same issues. It's by Susan Schneider. She's focused on it more from a philosophy and neuroscience perspective about how AI is changing us, and rather than us creating it. So she's talking a lot about how these algorithms at Facebook and all social media, even the search engines, they're all shaping our minds, and it's not in a good way. It's making us all much more extreme versions of ourselves, making us less human, really turning us into predictable agents ourselves, so that those algorithms can predict what our behavior is, because the more extreme we are, the more predictable we are, and then they know exactly what to advertise to us with. It wasn't the intent, and that brings us to what the problem is with all of this. The problem is, I guess I've kind of given it away here, but an intelligent agent is focused on meeting its objectives. So, but the problem is it's meeting its objectives. It's not meeting our objectives. And the reason why we can't program it with our objectives and tell it, hey, we want this, is because no individual human knows what our objectives are for society. nor do they know what they are for themselves. Probably within the next few seconds, they're going to change their mind about what their objectives are in the moment. And so it's really, really, really hard to try to program into a machine, which currently we've only been thinking about as having fixed objective functions or fixed loss functions or fixed scores or ways of scoring them on how well they're doing, with what our real objectives are for them. So if you think about there's the story of the paperclip manufacturing robot that is told to manufacture paper clips, and he eventually, if he's better at us, he will learn to manipulate all of us and corral all of our resources into making paper clips until we all starve to death, and we all have nothing but paper clips all over this planet until the planet is decimated. And so even something as simple as trying to optimize the production flow of a factory can turn wrong if you have a machine that that knows that it only has a fixed objective and it happens to be better at it than any of us, and we can't stop it. So it's not that they're necessarily malicious. Am I still live? Yeah, I guess. Okay, cool. I want to make sure that my internet's still good. And let's talk about, so that brings me to another objection. So that we talked about the slow progress being an objection. So you'd think that people like Andrew Ng, who are at the center of machine learning, but the problem is they are big proponents of it. Let me find the slide about that had that picture of Alpha Centauri. So there's Alpha Centauri out there, and he decided that this is like worrying because AI and generally intelligent AI and powerful AI that's able to, or what's called strong AI, which is able to beat us at our own games, is as far away and as remote as the possibility of us overpopulating Alpha Centauri. And Stuart Russell has a good comeback for that. And I don't know why Andrew Ng hasn't publicly acknowledged the logic of Russell's argument, but he says that, yeah, but there's not a whole planet of people trying to get to Alpha Centauri, spending as many dollars as they can spare on AI trying to get there. And even if there weren't, even if there were just a few people working on it, because the reason why everybody's doing it is because of this huge reward. But even if there are only a few people doing it, we should probably wonder what would happen if they did succeed. What if we succeed? So that's all Russell is doing, is saying, what's going to happen if we succeed? And let's make sure that we can succeed at something that's not going to destroy us and our planet and everything that means to be human. And so that's the crux of his book. Let me think, there was another argument. Well, I guess there was, the other one was, I guess it was a similar argument, a similar rebuttal, is that some other very smart person says that it's like worrying about a black hole spontaneously appearing in near Earth orbit and swallowing the planet. It's that kind of remote possibility. But Russell makes a good argument that it's likely to happen within a few decades. And at that point, it's game over unless we do something different, because we can already see the effect. And it's not that it's something that we even have to wait 30 years to find out. We're seeing it happen now. Let's see. And it's interesting that books like this have, like How to have Impossible Conversations, are coming out now and are very popular and very useful, because now we're having such and such greater division between people, and we're having a harder and harder time talking to each other. And so it's a great book if you want to try to. This is written by Peter Boghossian and James Lindsay. Peter Boghossian is one of them is a hostage negotiator, or was, and they're both brilliant psychologists and sociologists. A lot of good ideas on how to convince people that this is a real problem, and try to focus on pro-social AI or beneficial AI rather than just bottom line AI that improves your bottom line. That's what I got.
Thank you. Any questions before we move on to the last speaker? Yes, questions. Two of them. Has anybody defined what we want to do, what we want an AI to do, and what do we want it not to do? So, for example, if we develop it, then we would um, put in our values of the types of things that we want to do. But if the Chinese do something, they would put in something that would be according to their values. But some of their values might have the AI do things that we think it should not do. So have we actually defined what we would want it to do and not do, other than the usual things of don't kill off humanity and stuff like that?
Yeah, exactly. So those things like don't kill off humanity, they don't work. Russell goes through all the arguments about how Asimov's three rules of robotics, they just don't work. You can't build any rigid rules that are going to solve this problem. The only problem, but Russell does have a theory that he is proving, and maybe he has proven it, where there is provably beneficial AI. So you can make the one way that he proposes to do that is to give the AI humility. And so if the Chinese the Chinese are going to destroy themselves if they build an AI that is not provably beneficial. If it is able to, because it will escape its box, if it has any kind of, because part of its objective function will be include its own survival, and it will know that its benefit to humanity, and even Chinese humanity, even if it's narrowly focused on the Communist Party, can only be accomplished if it's alive and well, and it will put itself above all of the people around it until eventually it's using more electricity and people are living in squalor, and there's just no way out of this except to build it such that it has humility and it knows that it doesn't know what we want, and that its entire objective is to find out what we want, and find out what the human next to them wants. Because even the chairman of the Communist Party doesn't know what they want, and it needs to wait around and find out what they want. And even the chairman of the Communist Party is going to exercise some sort of mercy on those people, that we aren't all sociopaths. And so and the AI is going to know that it's not at the service of any one objective for any one human or any one country. It's going to know that it's in service of humanity, and it's trying to understand what that is, and trying to constantly adapt what it's doing in order to make us happy. So that's one of the approaches, and there's some way that Russell has come up with that we can implement in software.
Okay, if I may, a separate question. I don't know whether it's the right way to characterize it or not, but is there a way you can break the decisions down into what decisions are stochastic and which ones are deterministic? And let's say, are we 60-40, or is this
It's a 100% stochastic. It's all Bayesian logic. Yeah, that's the idea. Most machines have to deal with uncertainty, not unknown unknowns and unknowns about the environment. So they all have to play partially observable games, like like a self-driving car has to deal with somebody walking out from behind a telephone booth that they didn't see, and they never knew was there as they're driving down the street. So yes, they're all stochastic decisions.
Okay, I was reading a couple of books. One of them is this our final invention. But one of the things that I saw was that I don't know whether it's one of the computer games where they steal cars and stuff like that. I don't even remember the name of it. I don't play any of those. So anyway, they're
Grand Theft Auto.
yeah. Apparently they have incorporated physics into all of their things as far as their crashes and stuff like that. So if you've got things where they know that where they can do all the calculations, and we know how to do all those calculations, then that becomes a deterministic problem.
No, there are no deterministic problems, no matter how well you know the world. Any interesting problem has this kind of number at the end of it. Even a deterministic game like Go, there's simply too many possibilities. The atoms in that simulation of Grand Theft Auto and those explosions, you can't know where every piece of shrapnel is going to go. The AI doesn't know where every bullet's going to go. It's just Yeah, so complexity is a real thing.
Yeah, it just seems that there are certain things that are like when we design a bridge, we design it, we design it for certain safety factors and things like that, and we know how to do that because we've done that for a very long time. So it just seems like going back to classical AI and expert systems, that there are some things that we would just say, okay, we're not gonna have it deterministic, stochastic, anyway, probabilistically determine 2 + 2 = 4. We're just going to add them together.
Right. Yeah, we've already solved those problems. The hard problem, building a bridge is different from building an algorithm. It's just different.
Okay.
So, especially a self-replicating algorithm, a self-replicating, self-improving algorithm. So that's just a completely different thing. You're talking about building a bridge that builds bridges, and that's just a different thing.
Okay.
Any last questions before we move to the next speaker?
Have you come across any ideas on how to make an AGI's intentions explainable?
Yes, that's what Russell has, not me. So Russell talks about how it needs to explain to us why it's doing what it's doing, just in the same way that a human does. If it's generally intelligent, it will have the same sense and some sort of vague understanding or generalization around its emotions for why it's doing what it's doing. Many people believe that emotion is a big part of intelligence. So Einstein didn't come up with E = mc² strictly from doing math. It actually came to him because it was beautiful and it looked perfect, and it just came to him in an emotional, it felt right sort of feeling. And until we give machines that kind of sense of what the right decision is, they won't be able to make good decisions. And as soon as they have that, then they'll be able to explain what they were feeling and why they went down that path and why it was the right path.